Welcome to my mathematics class. I am continuing with the Fourier transforms. Here you see that I have taken a problem which is very important from the university point of view. This is very often asked in the university examination. And the second one is an application in Fourier transforms. This also will be done. You see that this is my, say you can call this as lecture 1. So I define, first of all, let me take this problem. You are given, say you are given f of x is equal to e to the power of minus x squared by 2 to find f of e to the power of minus x squared by 2. That is Fourier transform of e to the power of minus x squared by 2. So this is my problem. So you see that first of all we must write what is a Fourier transform. Say what is a Fourier transform? If you are given a function and that function, unlike the Fourier series, if I give that is a function unlike a Fourier series function, it will not be defined in an interval. It is defined over minus infinity to plus infinity. First of all, you must understand that. So you see that here, whenever a function is given, your Fourier transform is given by f of x, which is equal to f of s, which is equal to 1 by square root of 2 pi minus infinity to plus infinity f of x e to the power of isx and dx. And if you can find the Fourier transform of a function f of x, you can also talk about the inverse Fourier transform, in the sense that you can talk about this f minus 1 of f of s, which is equal to your f of x, and this is given by 1 by square root of 2 pi. It is minus infinity to plus infinity. It is f of s into e to the power of minus isx into ds. Now you must be very careful in writing the integrals, Fourier transforms, because you see that here, and these forms are not unique. Fourier transforms that I written on the board, they are not unique, in the sense that in some of the books you will not find this 2 pi 1 by square root of 2 pi coming, and in the some of the books you will find f of x e to the power of minus isx here, and this is plus isx. So likewise there are various ways of writing this, but my advice is stick on to one way of writing it and do the problems. So you see that I am taking in this way. So you see that this is called the Fourier transform pair, because this gives you the Fourier transform of a function f of x, whereas this gives you the what? The inverse Fourier transform. You can write like this, no problem, f minus 1 of this. So you see that this one you have got here. Now let me start doing this problem. Now you go by the procedure, write the formula correctly, and then you use your ideas of integration, and then you will get the answer. See we know that, I'll write here, we know that for f of x is equal to e to the power of minus x squared by 2, f of x, which is equal to f of e to the power of minus x squared by 2 is equal to 1 by square root of 2 pi minus infinity to plus infinity e to the power of minus x squared by 2 into e to the power of isx into dx. See, I have not done anything here except I apply this one. This one is nothing but the Fourier transform of any function. Here f of x happens to be your e to the power of minus x squared by 2. So I have written here. So you see that I will write this as, see, 1 by 2 pi square root of this into, I will write this as e to the power of minus x squared by 2 plus isx into dx. So I have used theory of indices. A to the power of m into a to the power of n is a to the power of m plus n. So you see that this is what I do. Now I will explain certain things here taking only the power of this e. See, what I am going to do is I am going to make this a perfect square. How to make it as perfect square? See, you have got like this. See, you take this minus half outside. So you are left with 2is. I hope that all of you can understand. I am going to make the power of this e a perfect square. So what I do is as a power you have got minus x squared by 2 plus isx. So I take this minus half outside. So you are left with what? E to the power of x squared minus 2 isx, this one. Even if you want, I will write this, no problem, I will write this. And see, you see that how will you make a perfect square? What is that you will do? Suppose you have got here x squared minus x. How to make it a perfect square? You divide this by 2 and see, you divide the x by 2, square that number and add that number, in the sense that you have got this, divide this means what? You will have a half of x plus it is 1 by 4 minus 1 by 4. What is that I have done here? Divide this coefficient of x by 2, so it will be half. Square that and add and subtract. So if you add and subtract, the value will not change. So what is this that you will get here? So this is x minus, see, this is x minus half whole square minus 1 by 4. So you see that here I am able to make this a perfect square. This you just see that you will get here, it is x squared minus x plus 1 by 4 and you take. So I have not changed the value at all. I am making it a perfect, so I make this a perfect square. Now, so likewise I am going to do something here. See, what is that I do is divide the coefficient here. What is the coefficient? 2is. Divide it by 2 and then you, whatever you get, you square that and add and subtract it. What is that I am doing is, see, for example, I write like this. So I will write it here itself. If you divide this, see, this is your coefficient. So divide it by 2, you will get is. So add is whole square and subtract this is whole square. Are you able to understand what I write here? So you see that you divide this coefficient 2is by 2, so it will be is. Square that, add and subtract. The value will not change, but at the same time you can make this a perfect square. Now what is that you will get here now? So this is nothing but, so this is equal to e to the power of minus half into x minus is whole square. So you see that what is that you get here? X squared minus 2xis plus is whole square. So I have got, and take this, you write this as minus, see, I squared is what? I squared is minus, I squared is plus, I squared is plus, I squared, it is yes, I is equal to square root of minus 1, I squared is equal to minus 1. So I squared is equal to minus 1. So minus 1, so this will be minus s squared. So this one, minus s squared. So I squared is equal to minus 1. So take this minus sign inside. So what is that you will get here? E to the power of minus half into x minus is whole squared into e to the power of. So this is minus into minus plus. Again this minus will come. So it gives you minus s squared by 2. So you see that if you're going to make this a perfect square, you will divide this by 2, add is plus is whole squared and subtract it. The value is not changed. Then you do this small manipulation, you will get this. So in this place I will write that. So 1 by 2 by 2 pi square root of this minus infinity to plus infinity, and it is e to the power of minus half. I'll write everything here. So x minus is whole squared into e to the power of minus s squared into dx. So this is what I will get. So this is, now this s squared, if you see that it is treated as a constant with respect to the integration with respect to x. So this is a constant, take that outside. So you will get this as e to the power of minus s squared divided by square root of 2 pi into minus infinity to plus infinity. I will write this as e to the power of minus x minus I root of 2 whole square into dx. I have not done anything difficult here. You just see that this is x minus is, minus is outside. If you take this to square root of 2, if you square it, this is x minus I whole square divided by square root of 2 whole squared is 2. So I am retaining as it is. I have not done anything. I am not changing it all. So this place is very, very important. This I am making it very clear how to do that. After doing like this, so substitute in this place. See, replace this by this factor and take this e to the power of minus s squared s squared by 2. It is minus s squared by 2 outside, because this has nothing to do with the integration and it is a constant. So take that outside and do that integration. Now let us start doing this now. So I will take like this. I will put it like this. Let x minus is divided by root 2 be your u. See, I go for change of variable, that is substitution like this. X minus is divided by square root of 2s. So this implies it is x minus is equal to square root of 2 into u. Okay. Now x tending to minus infinity implies u also tends to minus infinity. See, this tends to minus infinity, whether you add any quantity minus infinity plus or anything, that will be minus infinity only. So x tending to minus infinity implies u tends to minus infinity. X tending to plus infinity implies u also tends to plus infinity. And take differentials on both sides. So dx is equal to root of 2 into du. Now you see that, so these changes I will bring in here. That means change of variable I will do here. So what is that you will get here? Let me call this as your, so this is your f of e to the power of minus x squared by 2 is this. Okay. Now I'll rewrite this. That is f of e to the power of minus x squared by 2. So in this place, e to the power of minus s squared by 2 square root of 2 pi integral of minus infinity. For this change of variable also, for the integration limit is from minus infinity to plus infinity, and this is e to the power of, see this whole thing is x minus is divided by root 2 is t, so it is minus t squared into, what is your dx? Dx is root 2 into du. So this is what I get. So what is that you will get here now? So this is e to the power of minus s squared by 2 divided by, I'll write this as square root of 2 into square root of pi into, take the square root of 2 outside, so square root of 2, it is minus infinity to plus infinity e to the power of u square e to the power of minus u square into du. So you see that this root 2 and root 2 will go off, giving you what? So this gives you, e to the power of minus s squared by 2 divided by square root of pi into minus infinity to plus infinity e to the power of minus u squared into du. But it is a well-known result that, but minus infinity to plus infinity e to the power of minus u squared into du is equal to square root of pi. This I will prove on some occasion, but it is not required. Know that this is the standard result when you go for integration of e to the power of minus x squared dx. Any variable you put, e to the power of minus x squared dx is equal to square root of pi. Whether it is x or pi, t or u or whatever be the variable that you are going to take, it is true that e to the power of minus u squared integral of that e to the power of minus u squared du is equal to square root. So what is that you will get here? So e to the power of minus s squared divided by 2 into square root of pi into square root of pi. So this gives you simply e to the power of minus s squared by pi. That means what? They are self-reciprocal in the sense that now you see that f of that is the Fourier transform of minus e to the power of minus x squared by 2 is minus s squared by 2. So naturally you see that the inverse transform of this must be equal to this. So that is e to the power of minus the Fourier transform of this is self-reciprocal. That is, they are e to the power of that is f of e to the power of minus x squared by 2 is equal to e to the power of minus s squared by 2, and therefore f minus 1 of f of s is equal to f of x, which is also equal to L, that is self-reciprocal. They are self-reciprocal. So they are So this e to the power Fourier transform of this is nothing but self-reciprocal, because if you take the Fourier transform of this, it is e to the power of minus s squared by 2, and the inverse transform of this will be equal to what? Here it is equal to this one, e to the power, therefore they are self. So this is an important problem. Sometimes they give with e to the power of minus ax squared, something like that also. So take care of this. This is an important problem. Now let me pause on to the next problem. So this is over. So this problem is over. This is over. Let me pause on to the next problem. What is the next one? You have to find the Fourier transform of an integral function. Integral function means what? A function which is integrable, nothing more than that. Whether that is, here this function f of x is given that that integral value exists, definite integral value exists. That is why we say that what? That means this is the meaning of that. That is, it is f of x dx is less than infinity, in the sense that this definitely exists. It is existing. So such an integral function, it is an integral function. For such an integral function, you have to prove that this particular result you have to prove. See, what is that we will do here? See, Now let me start doing this. See, given f of x is an integrable function with, it has got a Fourier transform. f of x is equal to f of s. To prove f of the integral from a to x, f of x dx is equal to I by s into f of s. So this is what we have to prove. Now I'll prove this. Let a to the power of a to x integral of this f of x dx be equal to your g. Let you call this as your g of x. Nothing else. You just call this. When you integrate this, it is going to be a function of x and this. Now this implies that when you take the derivative of this with respect to x, this integral will go off. You will get f of x. Can you catch what I am telling you? So you see that if you take the derivative of this, actually speaking, dg by dgx divided by dx is equal to f of x, something like that. So you see that when you take the derivative of this, you will get this function. So this implies that this, actually speaking, I will tell you that d by dx of g of x is equal to something like this, f of x. So you go for cross multiplication, so this integral will be equal to your g of x. So g of x is equal to 0. So this implies that your f of x is equal to g dash of x, the first derivative of x. I will explain this. See, actually speaking, what happens is that your dg by dx is equal to some f of x. This implies that your dg is equal to, this is derivative, g dash. So dg is equal to f of x into d of x. So this implies that integral of dg is equal to integral of f of x into d of x. This implies that g of x is equal to integral of f of x into d of x. See, this is how it works. This is how this works. Therefore, I am writing this as what? Your g dash of x is equal to f of x. Now let us start taking this. Now, see, now f of x is equal to, it is f of g dash of x. This f of x. Now we have to find this and prove that this is equal to what? This I by s into f of s, if I have to prove this. Now, see, this is what you call this as your 1. Now, f of g dash of x, what can you write this? Now, this is a Fourier transform of a derivative. So, this is equal to, how will you write this? 1 by square root of 2 pi. It is minus infinity to plus infinity. And it is what? And it is equal to your g dash of x into e to the power of isx into dx. So this can be written as 1 by square root of 2 pi. It is minus infinity to plus infinity e to the power of isx into dg of x. Because g dash of x into dx can be written as g dash of x. So this is equal to, so this is equal to, now you can use this Bernoulli's method of integration, which is namely 1 by square root of 2 pi into, it is e to the power of isx into g of x minus, and this is nothing but, now you have to differentiate this, so you will get what? Is, if you differentiate this with respect to x, it is is into e to the power of isx into, what is that? Integral of see this one, into integral of minus infinity to plus infinity g of x into dx. Can you catch what I am writing on the board? So you see that for this one, no. So you call this as minus infinity to plus infinity. So you see that this one, 1 by square root of 2 pi, I used Bernoulli's method of integration here, e to the power of isx into g of x, and you have to now differentiate this with respect to x and then integrate. Now that is what I have done here. So this one for plus infinity and minus infinity, this term will become 0. So what is that you will get here? So therefore we get, see this g of x is for minus infinity and plus infinity, it becomes 0. So you see that even g to g minus infinity, this will become x is equal to minus infinity, this becomes 0, and for this also becomes 0. So you see that this will be equal to f of g dash of x is equal to, it is 0 minus, it is minus, take that outside, is into integral of minus infinity to plus infinity g of x e to the power of isx into dx. So this is what I will get here. So this one minus is, because it is a constant, I am taking that outside. So you will have this. Now I will write this as, so this is equal to, so this is nothing but minus is, this 1 by square root of 2 pi is very much there, 1 by square root of 2 pi, this is coming here. So you see that I will rewrite this. So this will be equal to this 0 minus is 1 by square root of 2 pi, it is minus infinity to plus infinity g of x e to the power of isx into dx. Okay, now you see that I will put it in this way. Why should I put it like this? Okay, now this is equal to minus is. What is this? This is a Fourier transform of g of x. So this is equal to f of g of x. F of g of x. Now you see that here f of g of x, but this, call this as 3. Call this as 3. Now, so you see that g of x can be written as a to x into f of x dx using 3. So I have not done anything. I am doing my work and carefully watching what I am doing, because unless I take care to write properly, even a small mistake can lead me to a wrong answer. So you see that I have come here. As I told you, this particular part is 0. So I have taken this and I am writing it here. Here I will write it here for your understanding like this. It is square root of 2 pi into is. So is into 1 by is. See, is divided by square root of 2 pi. But this I write it as minus is, I take it outside and write the whole lot here. But I know that this is nothing but the Fourier transform of f of x. So I write this is into f of g of x, that is minus is into f into this one, because I know that this g of x is equal to what? Your g of x is equal to a to x. This is my this thing. G of x is equal to a to x f of x dx. So you see that, so in the place of g of x I can substitute here. Now, so this implies, I'll write, so this implies I'll write here minus is f of integral of a to x f of x into dx. This implies f of a to x into f of x dx is equal to minus 1 by is into f of s. Now, what is that you get here now? So this is multiply the numerator and denominator by I minus 1 into I divided by I into s into f of s. So you see that this is minus I into I is I square, that is minus 1 into s into f of s. So this is equal to minus and minus goes off, giving you what? I by s f of s. So I got the answer. So what is that I am having? For that is, this implies f of integral of a to the ax f of x dx is equal to your I by s into f of s. So this is what. So that is what I have proved here. So this is what. So here you must understand that when you take this as g, and therefore you see that your g dash is equal to f of x. Now you see that from here one step I'll write here. So f of g dash is equal to your f of x. So you see that you have found this f of g dash of x. This is equal to your f of s. F of g dash is equal to f of s. So you see that here I have written here f of g dash of x is equal to f of s. Do all those works and come to this place and take g dash of x, that is where g of x at minus infinity plus infinity, they are taken to be zeros. So you see that they are continuous and zeros, and therefore you see that you get this particular result, which is what we have to prove this. So these two problems have been done. I'll take more problems in the coming days. Thank you.